For lesson 7 homework, we're going to talk about some of our constructions in parallelograms. So the first one wants us to construct an altitude of parallelogram ABCD from vertex D. Now in class, the way we did this was we did it from vertex C, which meant we had to extend our line. But for this piece here, because we're doing it from vertex D, we want to take a look to see if we have to actually extend our line or not. You might have to mess around with your compass, but the way I look at it here is I can see I can get two very distinct intersection points. So I make my smiley face. So remember, this is perpendicular from a point off the line construction. So it does not matter how big that first circle is. It just matters that you are able to get it to intersect that bottom side twice. You keep your compass the same exact size to make your next two arcs from each of those intersection points. And then our altitude is going to be that line from vertex D down through that intersection point, and that creates our altitude and our right angle. For the second one, we want to construct the perpendicular bisector of RU in our rhombus. So in order to do that, we need to set up our compass so that it measures side RU perfectly. So there it's set up for our first circle. We are then going to flip it to make our second circle. And then in order to make our perpendicular bisector, we're going to draw a line that connects our two intersection points. So it's going to take me a second here to just grab this line and slide it so that it intersects perfectly. And there we go. Now we have our perpendicular bisector through side RU. The third one wants us to construct the angle bisector of RUT. So in order to do that, we need to make a circle around angle RUT, however big we would like. But the whole goal is we just need to get two intersection points. I'm going to make that line up a little bit better. So there's our first circle. Keep our compass the same size the whole time. And we are going to, from one intersection point, we'll make another circle. Then we will slide over to the other intersection point, and there will be our second circle. As we now draw our angle bisector, remember angle bisectors are rays. So when we do that here, there is our line, or there's our ray, which has just magically disappeared. So I'll draw another one there. And that's what we end up with. So there's a follow-up question on the bottom here that says, what do you notice about the angle bisector of RUT? And what do we think happens? Well, if you look, if you did this correctly, your line should, or your ray should perfectly intersect at angle S. So what it does is it forms diagonal US. Now, why does this happen? Well, a property of rhombus is that the diagonals bisect the angles. So because we did an angle bisector to angle U, we are going to end up with one of our diagonals. This would not happen in a rectangle, this would not happen in a parallelogram, but because one of the properties of rhombus is that the diagonals bisect the angles, when you do an angle bisector to one of them, it's going to form your diagonal.